So no questions on the chat? Anything? How's chapter 8 test? Am I broadcasting? I don't even know what I'm doing here. There we go. I'm broadcasting. Easy peasy, easy. Pretty easy. Chapter 8. Okay. All right. So everybody's good with chapter 8. So that means that we are on to chapter 9. So chapter 9, we started on Monday. I know Greta and Caitlin were out. Greta, I hope you enjoyed your concert. I can't blame you. All right. So we talked about the distance and midpoint formula on Monday. And I think everybody was pretty good with that. The distance formula we actually derived from the Pythagorean theorem. So if you would like to see the derivation of that, I'm sure you could also Google something on YouTube and it will show you. You found that easy? Awesome. And if you hear like that there, I just paused because I was getting a drink, so you didn't have to hear me clearing my throat. Okay, so then section 9.2, we talked about parabolas, right? And we have this nice little chart here that helps us to figure out the different points on a parabola. So we didn't quite get through that, so we're going to do that today. This one is not as hard as it looks. Yeah, midpoints are easy. I agree. And actually distance not too bad either, excuse me. So actually Desmos is pretty cool, right? We all agree Desmos is cool. That's not the one I wanted. Maybe this one. Well, if you did the parabolas, Elijah, then you're good to go. It's all good. Yeah, you're like, what just happened? Okay, so Desmos actually has a cool little, if you type in Desmos parabola, Desmos actually has this cool little, you did it the hard way. Well, this isn't, you don't plug it in here. I'm just kind of showing you that what the different things that we're talking about are. So I'm showing you what the parabola is. So remember, a parabola is our bowl shaped like this, right? The formula of a parabola is no, you can't just plug it in here. Yep, that's right, Elijah. So the very, 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 very simple formula for a parabola is y equals x squared, right? Okay, sounds good, Mackenzie. Or it could be x squared equals y. Those are two different parabolas that go different ways. Yeah, that's what I'm saying, Elijah. We're going to get more complicated than that, but these are two of the major parabolas, right? Okay, sorry. I'm reading. You're already done. Well, that's a good thing. Okay, so let's just talk about this. This is the shape of a parabola, right? There are two new-ish, maybe you've heard these before, newish terms that we learned on Monday, and one is the focus and one is the directrix. Okay, so the focus is actually this point that's shown in gray right here. And the focus is what the parabola is basically focused about. I mean, if you think of the word focus, right? The parabola curves around this focal point, this focus point. Okay, and then we have another point that's called a line that's called the directrix, and that's indicated by this red line down here. Okay, and so the focus and the directrix, let me make this a little better. Okay, let's make it really, really easy on ourselves. Okay, so the focus and the directrix are always equidistant away from the parabola. So what does that mean? That means if I draw a line from the focus point to the parabola, and a line from the parabola to the directrix, then these two lines are the same length. Okay, this is a really easy one. If I draw a line from, which shift worked here? If I draw a line from the focus point to this point here, you can see it's 4 units away. And then I draw a line to the parabola down here. From the parabola to the directrix, it's 4 units away. 1, 2, 3, 4. So those are the two terms that we learned yesterday or Monday that are kind of new, right? The focal point and the directrix. What's nice about Desmos is that, and I'll explain what all these mean in just a second. It is easy enough, right? What's nice about Desmos is that you can kind of play with this, right? You can say, well, what happens if you have a focus point that's closer in? So if your focus point is closer into your parabola, then your parabola has a greater curve, right? It's got this nice bow shape, and then if it's really, really close, get a super big parabola. Okay, and then obviously if you move it out, then you get a wider parabola. But still, if you would take your ruler and you would measure from any point, it doesn't matter what point it is. So if I measure to right here on my parabola, then this distance that I just drew is going to be the same as this distance if I drew a straight line. Okay, now when in our chapter, what we're talking about, so this is actually skipping ahead a few sections, but really what we talk about is when our formula is just x squared equals 4py. Okay, so what in the world does that mean? Well, this is how we can actually determine where the location of the focus point is and where the location of the directrix is. Okay, so in this particular case, our focus point, I was trying to get really close to 4, but our focus point is at 4, and our directrix is at -4, even though I'm not quite there. Okay, so that's a cool little thing I think it's cool that you can actually see online how that interacts with each other. So let's flip back over. So this is from your notes. This is on 9.2. And I actually just copied the page out of your book because I thought it was helpful. One of the things, good question. So Elijah says, one of the things that confuses me is I figured out that the directrix always is the same distance away from the vertex, which is true, Elijah, as a focus. Why is it like that? Well, by definition, the directrix and focus are always the same distance from each other, right? So in order to be the same distance from each other, when you're talking about this vertical axis, then this distance here, right along the y-axis, has to be equal to this distance here. And the only way those two are equal is if they're both equidistant away from the center. Did that help? I'm not sure. Sure. Okay. All right. So if you'll see on here, there's 4 different types of graphs. So if we flip back to our friend Desmos again, just regular old Desmos. We have our first graph is x squared equals 4py. Okay. Let's see if x squared equals, oh, good. I can add a slider. Here we go. Okay, so when we have, this is kind of the standard equation for your standard parabola, right? This is the parabola you think of when you think of parabolas, right? Totally, right? This is a parabola that opens up. It is symmetrical about the y-axis. Its vertex, remember, don't forget what a vertex is. The vertex is the highest or lowest point. Its vertex is at 0, 0. So this is about as simple as you can get, right? So why did I write this 4py here? Well, actually, let me do one other thing. So we've got x squared equals 4py. The second graph that's described on your page, so this one right here, happens when we actually change this to x squared equals negative 4py. So all we did is add this negative sign, right? And then our parabola, instead of opening up, is opening down. Okay, so far so good. Then we've got a third and fourth graph down here at the bottom. Okay, so these graphs actually have the equation of y squared equals 4px. I don't know if it's going to let me have two sliders. Oh, it is. Okay, so can you see the difference in the equations? Here we have x squared equals 4py, or negative 4py. And then this equation, we have y squared equals 4px. So depending on where your squared sign is, depends if your parabola opens, this one opens up. And then if we have the y squared, then this opens to the side. And if I make this negative, then it's going to open to the left side. So that's what these four graphs that are sitting on your paper right here represent. Okay, now what is this P business? Why do we have P? Elijah can tell you, right? Because he's done his homework already. So let's go back to our basic equation here. X squared, it's like, I'm done. X squared equals 4 times P times Y. So what this means is if I have an equation, like, for example, I'm just trying to think how to best, okay. If I have an equation like x squared equals, let me switch to my pen here, x squared equals 8y, okay? And I, all right, no problem. All right, if I have an equation like this is supposed to be x squared equals 8y, okay? And I wanted you to graph it, tell me what the axis of symmetry is, and tell me what the focus point is. Well, this is our standard equation for parabolas that open up. And I know this is a parabola that opens up because it's in the same form. So you'll notice the difference is, in here I have 4py, and here I have 8y. So everything else about the same, the two equations is the same. So what that means is that I can take this 4p and this 8 that is here and set them equal to each other. So 4p equals 8, which means that p equals 2. Okay, did everybody follow that all right? You guys still with me? Okay, so then if I just go to graph x squared equals 8y. Okay, I'm going to graph that and let me see it. And I change my focus point to 2. I end up with the same graph. And Elijah is exactly right. So why do I care what P is, right? Because P is really important in telling us where the focus point is and the directrix. So the focus is always at, let me draw on here. The focus is always at 0, comma, P. So since we figured out that P is 2, the focus point of this parabola is right here. This is my focus point. And the directrix is always at, oh, I didn't mean to do that. Y equals negative P. So if P is 2, Y equals negative 2. That means that my directrix is right here at Y equals negative 2. Okay, so now if I flip back to my original notes, you'll kind of see this is all confirmed. I have x squared equals 4 times P times Y. I figured out what my P was, right? Okay. So that means that my focus point is at 0, 2, and my directrix is at Y equals negative 2. And the vertex is at 0, 0. So not too bad, right? Let's go over here. Since this is like the official Desmos, or, let's see if we can add an item. Okay, so my original equation was what? X squared equals 8y, right? And I said that my parabola, in order to have that, would have a p-value of 2. So now you can see that my graph, both graphs match up, right? The red and the blue are on top of each other. And the focus point is at 2, and the directrix is at negative 2. So in order to do these problems, it's actually not really hard, because what you're going to do is you're going to set whatever number is before your term equal to 4p. It's actually not too hard, but I really want you to understand why we're doing it, other than just randomly figuring out what p is. So is this kind of clicking a little bit? Everybody still here? Awesome. Thanks for replying. Okay, so let's look at these example problems. Okay. I think we did number 1 in class, but I can't remember. Did we do number 1? Anybody? You don't know? All right. We'll skip to number 2. I think you guys are smart. You read it. Sorry, I was just looking at your homework in your book. Okay. Yeah, you guys will be good. Okay. So number 2 says x squared equals 2y. Whoa. It's my writing from before. X squared equals 2y. So, yeah, that's fine. So what kind of parabola is this going to be? Does anybody know just by looking at it? Is it going to open up or down or left or right? Does anybody have a guess? Daniel says up. I agree with Daniel. This is kind of our standard equation parabola, right? And if you need your reference chart, you can go back up here. So this looks like x squared equals 4 times p times y. Okay, so x squared equals 2y. So this looks like the equation x squared, doesn't like when I write squareds, equals 4 p y. Okay, so when I'm actually figuring, yep, that's right, Greta. So the first thing I want to do is graph the equation, which we can do in Desmos. We'll kind of skip back to that. I want to identify the focus, the directrix, and the axis of symmetry of the parabola. So I know that these two equations match up. The 2x squares matches up, the y matches up. So I know that this 2 and the 4p have to equal each other. So I know that 4p has to equal 2, or p has to equal 2/4, or it's supposed to be a 2, 1/2. Okay, so without even graphing this, I can tell you that my focus focus is going to be at 0, 1/2, and that my directrix, we're just going to abbreviate it, is going to be at y equals -1/2, and the axis of symmetry. So you guys all said it opened up. All of these don't have any of the other terms. So the axis of symmetry is going to be the y axis. Okay, so now if I go back to my original equation, let's clear things off a little bit, and I go into Desmos, I can check that this is all true. I mean, that I have the focus, the directrix, and the axis of symmetry correct. So my original equation is x squared equals 2y. Okay. Totally clear on there, right? X squared equals 2y. That's my equation, right? We're going to leave alone these values for h and k. I didn't mention those before, but you see in this equation, that's how you're going to shift your equation left and right, and we'll talk about that in a future chapter. So I don't know if it'll get mad at me if I delete these out. No. All right, it's not too mad at me. Okay, so we said that P is equal to 1/2. Not that close. There we go. P is equal to 1/2. So that means that my two parabolas do overlap each other. So I did that right, right? Oh no. That was really weird. I just got kicked off of Desmos. Or not Desmos, TeamViewer. You guys still out there? All right. That was really bizarre. I never had that happen before. Okay, so yeah, there's a bunch of labels on here, but that's basically, so now any point, right? So the easiest point to check is, yeah, sorry about that. Easiest thing to see is, oh, if I go from the focus to the parabola and the parabola to the directrix, they're both 2 units away. That's the easy one to check, right? All right, so that's how we do that. Any questions? Pretty straightforward, I think. It's not too bad. Okay, so let's try problem number 3. We have y equals negative 1/4 x squared. So does this look like the standard equation for a parabola? The fact that I'm asking that question probably means not, right? It's not, right? Because usually we have like x squared equals something times y, if it'll let me write x squared. But right now I have x squared is being multiplied by 1/4. So we have to use a tiny bit of algebra, but not that bad, right? So if I have y equals negative 1/4 x squared, and I want to get x squared by itself. Why do I want to get x squared by itself? Because if you go up to all these formulas up here, the x squared is either by itself or the y squared is by itself in order to match up to our formulas. So we need to get x squared by itself. Okay, so what can we do to get x squared by itself? Well, we can multiply by the reciprocal, right? In this case, we're actually going to multiply by so the reciprocal of 1/4 is 4, or 4/1, right? And while I'm at it, I'm also going to multiply by a negative sign, because that way I'm going to get everything from the right-hand side over to the left-hand side. So if I multiply this side by negative 4, basically, I have to multiply this side by negative 4. So what happens over here on my right-hand side? 4's cancel out. Obviously, 1's cancel out. Negative times a negative is a positive, and I'm left with x squared. And on my left-hand side, I'm left with negative 4y. So now I'm to my regular formula, right? So the standard formula is, I'm going to write it flipped. X squared equals 4py. So basically that means that 4p, come on, 4p has to equal negative 4, or p has to equal negative 1. All right, so without graphing it, this is what I'm trying to do. I know that my focus is going to be at 0, negative 1. And that means my directrix is going to be at y equals positive 1, because it's the negative of negative 1 is positive 1. And my axis of symmetry is going to be the y-axis. So let's graph it and see what we get. So our original equation is y equals negative 1/4 x squared. Y equals negative. Okay. And we said that our p value, right, where our focus point is at negative 1. So that's good. Our two graphs overlap with each other, right? And our focus is down here at negative 1, and our directrix is up here at y equals positive 1. Okay, one more example, right? Because we actually have not done this case yet. We have had all of them where they're x squared equals something. But look at number 4. We have x equals 1/3 y squared. Whoa. Let's erase that off of there. Okay, so we have x equals 1/3 y squared. So this isn't in the standard form, right? We want y squared or x squared to equal something. So we need to get y squared by itself. So we're going to do that by multiplying by the reciprocal. So the reciprocal of 1/3 is 3/1. these guys all cross off, right? So I get y squared equals 3x. So what happens when I have a y squared instead of an x squared? Well, what happens is that my parabola is going to open to the sides versus up or down. And because this is positive, we're going to get a parabola that opens to the right, like this guy right here. Okay, so our parabola is going to look something like this. Just a rough guess, right? Same idea though. We have y squared equals 4 times p times x. If you reference back up to your paper up here, you can see through my writing that when we have y squared, it's y squared equals 4 times p times x, right? So let me clear up my space here a little bit. That means that four p equals 3, or p equals 3/4. Okay, so here's where it gets a little bit tricky though. Before, we would just automatically say that my focus point is at 0p, right? But this parabola is actually opening this way. So my p value is for something that starts with 3/4, right? Okay, so the p value is actually going to, the focus is what the parabola moves about. So the focal point, just without even looking at my chart, is going to be here. Yep, exactly. It flips, right? It's going to be, instead of at 0p, it's going to be at p0. And my directrix, instead of being at y equals, it's going to be at x equals negative b. Okay, so we know p equals 3/4, so that means that my focus point is at, come on, let me write this. My focus point is going to be at 3/4, 0. And my directrix is going to be at x equals negative 3/4. I should label these directrix, focus. And this is going to, well, no. Ignore that, go back one. This is going to be my axis of symmetry. This totally looks clear. Now that I look back, this page looks completely clear, right? Okay, so if you go up, I'm going to turn off all my crazy writing for a second. If you go up here, we were basically following this chart, right? This is what our formula looked like. Our focus point is at p0 versus that 0p, and our directrix is that x equals negative p. All right, so let's see, Elijah's got, there's a chart. One of the instruction pages of the book tells you a list of all the things that change when the parabola is sideways and when the parabola is vertical. Cool. Do you know what page it is? Is it the 9.2 page or is it a reference page? All right, well, if you find it, let me know. So now, yes, so that page I actually think I copied out of 9.2 in your notes too, because I think it's good reference. So I think we understand that. If we go in Desmos, I don't know, I think this might actually fail us for this particular one. Maybe we can just, so this equation, instead of a x squared equals 4py, is y squared equals 4px. Maybe. Okay. And we said that our p was at 3/4, which is 0.75. See if I can put in a value. 7.5. No. All right, and our equation was x equals 1/3 y squared. All right, so maybe you have to find a different Desmos calculator because this only works for focus and directrix that are opening up or down. But our two graphs match up, right? Our blue and our red graphs do match up. But in terms of Desmos actually showing you the point, it kind of fails there. But we don't need Desmos to tell us, right? We know that our directrix is at, not there, our directrix is at 3/4. So it would be like here-ish. And our focus is right here at 3/4 0, and our directrix is somewhere over here at x equals negative 3/4. Cool. It's amazing, right? So your homework is 3 through 21, I believe. So you're going to be doing this just over and over again. Graph the equation, identify the focus, directrix, and axis of symmetry for the parabola. Any questions? You guys feel confident to do it? It's exciting. Can't wait to start. Yes, this is 9 too. All right. So I did want to mention this. I just actually want to get your opinion. I found on Desmos that they actually have classes on Desmos for this different concepts. So like, for example, this actually shows you how to move the directrix where the focus, the vertex is, what the definition of the parabola is, and then actually has you do a little homework in there. So I'm not going to make you do this for parabolas, but they have it actually for circles and for, I think, the next sections that we do. So, ellipses, they have it for ellipses. So I need to go through the ellipse one again and the circle one again. But when you get to the circle and the ellipse homework, I may actually have you guys try doing your homework online at Desmos. No, I just said that I'm not going to give you, the parabola homework is the parabola homework that's on your sheet. But I may change your circle and your ellipsis homework to on Desmos. Because I think it's actually interesting. Yeah. So just FYI, I'm not sure if I'm going to do it yet or not. There was one more thing I wanted to show you. Please don't. You would rather just do your homework in there. I didn't say more homework. I just said instead of homework. I don't know. I'll think about it. So coming, I feel like it's a trap. You guys are afraid of anything new. All right. This is what I'll do then. We have 10 minutes left. Well, technically 12, but I'll give myself 10 minutes. I'll actually show you what this one looks like for circle because that's what we're actually going to start in class on Monday. And so I think it's actually really helpful to kind of help you think through it. So we're going to skip the warm up. Okay. We're going to talk about what a circle is on Monday. So this is 9-3. So this, look at Desmos, you get moving parts. You don't get this when I'm drawing on the board, right? So what is a circle? A circle is a collection of points equidistant from a fixed point, right? So what is the center of the circle? Does anyone know where the center of the circle is? Center of the circle. There you go, Greta. Boom. The center of the circle is 0, 0. What is this crazy looking rotating orange dotted line? What does that represent? The radius. There you go. Radius. Love it. So if you have the center of a circle, every point on the circle is equidistant from the center. And we call that distance the radius, right? So that's just showing you what the definition of a circle is. Okay, so what are some things that we can do? We can write, actually, you're kind of lucky, because in 9-3, all of our circles are going to have a radius of 0, 0. Okay, so if we change the distance from the radius to the outside of the circle, it's going to be shocking. The circle is going to grow larger, right? So if I change the distance from the radius to this point and make the distance 5, then the distance anywhere from the radius to the circle is also going to be 5. Yes, shocking, exciting. So this is just having you play with Desmos. It's saying like, okay, make this circle the size and the circle the size. You can change it with your cursor. This is super exciting stuff, right? Yes. Obviously, I didn't really this again. Okay, so this is the standard form for writing equations of circles. And actually in 9-2, we're going to actually make it even easier than this. So the standard form of an equation is x squared plus y squared equals the radius squared. Has anybody seen this equation before? X squared plus y squared equals radius squared. All right, so I feel like I'm not as prepared for this as I thought. So we're gonna, what? Like I was busy and then all of a sudden this happened. Yep, there's some geometry coming back. Nope, you're not in the wrong class. Okay. This is Algebra 2. So I think I should just stop there. Stop while we're ahead. You guys are ready to do parabolas. It's not that much geometry. Because they're so funny. I'll stop here. You guys make sure you work on your parabola homework. Your chapter 8 test is due on Monday. We will talk about circles and ellipses on Monday, possibly. Yes, those are the two that we'll be talking about. Yes, on Monday. So this whole chapter, just to give you a heads up, is all about graphing and identifying different, I call it conic sections. So, excitement. All right. Thanks, guys. Sorry for, or thanks for sticking with me for a few minutes while we played with Desmos. You had to make a circle. Guess how you did it? You used I don't know, how'd you make your circle, Elijah? Use Desmos to make your circle. All right. See you later, guys. Thanks for coming. Have a good day. Bye.